Here we have another example of converging triangles. They're pointing in on one another. The best thing to do is redraw them so you have one big triangle, one little triangle. So I'll draw this big triangle here, and then my little triangle. And I'm going to set them up respectively. So I'll say triangle A, B, C. There's the big triangle in the diagram. And then this has to be E, F, D. So I go E, F, D. Now as I set these triangles up, I want to make sure that I retain their values. So the big triangle had a vertical height of 35, and the little triangle had a vertical height of 25. Now what's confusing on this was I gave you 3 breaks, or 3 different dimensions, so we have to pull those together. And that's why I showed earlier the idea of being able to add segments. If I want to walk from here to there, and then here to there, in other words, for B to C, you'd have to add those 2 expressions up. So 5R and R would produce a distance of 6R. The 3 and the negative 4 would be minus 1. In a similar way, I'm going to travel the same distance twice. If I want to go from here to there, I have to add this expression with that expression. So 5R and R is going to produce 6R. Negative 4 and negative 2 would be minus 6. When I set up the proportion shouldn't be that confusing. It's just going to be a vertical to a horizontal as a vertical is to a horizontal. You may want to do it a different direction. You could say vertical for the big triangle is vertical to the little triangle, as horizontal is for the big triangle, as horizontal is to the little triangle. Just be consistent when you set up a proportion. I'm going to go with these 2 numbers to show you a different idea here. If I say 35 is to 25, as 6R minus 1 is to 6R minus 6. Remember that you are allowed to reduce numbers. This is just a fraction here. So when I look at this, I do recognize that the fraction reduces. I could divide the top and the bottom by 5. That would simply be 7 over 5. Now that sets me up with a little easier equation to solve. I still have to multiply by the common denominator. And so I'll multiply by both a 5 and a 6R minus 6. And as I distribute this, the 5's would cancel out on the first distribution, and I would have 7 times 6R minus 6. For the second distribution, the 6R minus 6 would cancel out, so I'd have 5 times 6R minus 1. Now I want to solve this. As I solve it, this would give me 42R minus 42 is equal to 30R minus 5. As I move my terms appropriately, I'm going to move this 30R to the left, 42 to the right. I could write this as 42R minus 30R equals negative 5 plus 42. 42R, take away 30R is 12R. And negative 5 plus 42 would be 37. So I could divide by 12. Again, I get a strange answer there, and that's okay. That'll be 3 1/12. So I can come up here and say R was equal to 3 1/12. But rather than just solving for R, I want to know the lengths of those sides, so I have to plug those back in for R. And so I'm going to say 6R minus 1 would be equal to, and then again, I just use my calculator. I can say 3 1/12 times 6 minus 1. That gives me 17.5. And then I want to do 6R minus 6. So I'll say 3 1/12 times 6 minus 6. I get 12 1/12. which makes sense. They should have only been 5 apart because of the way those expressions were written. But oftentimes they're not that easy. You have to actually plug them in, figure out what the lengths are. Here is our second example of having triangles that are converging. They're pointing towards one another.